Section 6.3, double angle power reducing and half angle formulas. All right, let's take a look at double angle formulas. If we had a sine of 2 times theta, we could write that as 2 times sine of theta times cosine theta, tangent 2 theta, here it is, and cosine of 2 theta, and it takes on 3 forms here, okay? And you could get from this form to either one of these 2 forms by substituting in Pythagorean identities. All right, so let's commit these to memory. I have to erase them now because I need a board space. So let's take a look at our first example, see how we're going to use these formulas. All right, our first example reads something like, find the exact function value. Find the exact function value. In part A, we have what? Cosine of theta is equal to -5/8, and theta's in quadrant number 3. And then they want us to find a sine of 2 theta and tangent of 2 theta. Find sine of 2 theta and tangent of 2 theta. All right, so let's see. I need to start somewhere, okay? Eventually, I'm going to find a sine of 2 theta, which I'm going to use the formulas I had. And tangent of 2 theta, I'm going to use the formulas we just had. Let's start with this, okay? Let's start with an angle theta, whose terminal side is in quadrant number 3. All right, that'll look like an angle theta like this, whose terminal side is in quadrant number 3. Now, let's make a right triangle right here, okay? And use that. Now remember, we're going to be using a reference angle here. We could call it theta prime, but it has the same sine, cosine, tangent, and so forth as theta does, right? So if the cosine of theta is -5/8, the cosine of theta prime would be -5/8 as well. Well, what's the cosine of this thing? Isn't it adjacent over hypotenuse? So that'll be -5/8 for the cosine to be -5/8. Now what I need to find is the length of this side of my triangle B, okay? So according to our Pythagorean theorem, a squared plus b squared is equal to c squared, right? And if we end up solving for b, we get b is equal to plus or minus the square root of c squared minus a squared. Verify that for yourself. All right, b. B now is going to be, yes, the side of this triangle right here, but technically what is it? It's the same thing as the y coordinate right there, right? And the y coordinate is negative in this quadrant, so my b value is going to be negative here. And it's going to be square root of c squared, which will be 8 squared, minus a squared, minus -5 squared. All right, let's clean that up. B is equal to negative square root of 64 minus 25, right? What is that, 39? So B is equal to negative square root of 39. So over here, I can call this B negative square root of 39. Now, I did all that to find these values. My sine of 2 times theta was what? Think about what we had on the board over here. 2 times sine of theta times cosine of theta. And that's just that double angle formula. So to calculate that, I'd say 2 times, what is the sine of theta? Look at this triangle. What is the sine? The sine will be opposite over hypotenuse, right? So it'll be the square root of 39, or negative square root of 39, over 8 times the cosine of theta. Well, look at your triangle. What's your cosine? -5 over what? 8. So I'm going to say -5 over 8. Now let's calculate. All right, so what is this going to give me? That's 2 times -1 times -5 gives me positive 10 square roots of 39 in my numerator. The denominator is going to be 8 times 8, or 64, right? Now I can simplify by dividing these both by 2, so I get 5, and I get what here? 32. So that's 5 square roots of 39 over 32. And that's what the sine of 2 times theta would be. Well, what else do I need to find here? I need to find a tangent of 2 times theta, right? So let's find that. What is the tangent of 2 times theta? Well, that's 2 times the tangent of theta over 1 minus the tangent of theta squared, according to those formulas we had on the board. Well, let's fill in here. So up top, we're going to have 2 times, for the tangent of theta, I'm going to use opposite over adjacent. So I'm going to use negative square root of 39 over negative 5. And is it a negative over negative a positive? Over 1 minus tangent of theta squared. Well, we just said the tangent of theta was the square root of 39 over 5, right? So let's turn that mess into something nicer. That'll be 2 square roots of 39 over 5 up top, right? Down below, what do I have? 1 minus 39 over 25. Well, that gives me 2 square roots of 39 over 5 up top. But down below, isn't 1, or can't 1 be written as 25 over 25? Isn't 25 divided by 25 1? Minus 39 over 25, just coming up with a common denominator here. All right, so what does this give me? This gives me 2 square roots of 39 over 5, all over, it's going to have a denominator 25, and what's 25 minus 39? That'll be a negative 14. Now, what do you do to simplify this? When you divide fractions, you multiply by the reciprocal, right? So let's see, we have 2 square roots of 39 over 5 times 25 over 14, which is a negative, right? All right, let's see what we could do here. We could say, okay, 5 divided by 5 is 1, negative 25 divided by 5 is negative 5. 2 divided by 2 is 1, 14 divided by 2 is 7, right? So what do I have left? 1 times negative 5 times the square root of 39 is negative 5, square roots of 39, all over 1 times 7. There we go. There's my tangent of 2 times theta. Tangent of